This is the AquaAct instructional video.
We made this video to show you how to water test.
This is our logo that we made to represent our project and what it means.
Here are the materials that you will need for testing.
Now we'll tell you about pH and why it's important. pH is the measure of acidic or basic quality of water. The pH scale ranges from a value of 0, very acidic, to 14, very basic, with 7 being the neutral. This is the section of the chart you will need to compare with. Most aquatic life prefer a range of 6.5 to 8.0. pH can be affected by atmospheric conditions, weather, acid rain, wastewater, discharges, drainage from factories, and much more. pH can also decrease due to decaying vegetation. They are adapted to a specific pH level and may die, stop reproducing, or move away if the pH is outside of their desired range.
The pH wide range procedure. First, you collect your sample in the bucket. Then, you fill the plastic test tube to the 10 milliliter line. Add 1 pH wide range test tab. Cap and mix by shaking until the tablet has dissolved. Compare the color of the water sample to the pH wide range color-coded chart. The color should be in a range of 6.5 to 8.0. Record it on a piece of paper. Stop and try it.
Now we'll tell you about temperature and why it's important. Aquatic plants and animals are sensitive to changes in water temperature and require a certain temperature range in order to thrive. Water temperature also determines how much oxygen is dissolved in the water for aquatic life. That's the tabs that you will be using to test. Cold water holds more oxygen than warm water, and all aquatic animals need oxygen to survive. Temperature also affects the rate of photosynthesis of aquatic plants. Warm water discharged from factories, the removal of trees that shade streams, and water that runs out of city streets can cause temperature changes to threaten the balance of aquatic systems. That's a sewer drain. The temperature procedure.
Put on your gloves and place the thermometer on the bucket. Place the thermometer 4 inches below the water surface for 1 minute. Take the thermometer out of the water.
The number with the green/brown background is the temperature. Record it in Celsius. Stop and try it. Now we'll tell you about DO and why it's important. Dissolved oxygen is important to the health of aquatic life forms. Natural waters with consistently high dissolved oxygen levels are most likely to have healthy environment and are capable of supporting a diversity of aquatic life forms. That's the section of the chart that you will be comparing. Dissolved oxygen can hold more dissolved oxygen than warm water. For example, water at 28 degrees Celsius will be 100% saturated with 8 ppm dissolved oxygen. However, water at 8 degrees Celsius can hold up to 12 ppm of oxygen before it's 100% saturated. High temperatures caused by high turbidity, a loss of trees shading a body of water, or an increase in air temperature can cause dissolved oxygen to decrease. High levels of bacteria or large amounts of rotting plant can cause the percent of saturation to decrease. These changes can affect the ability of plants and animals to thrive in their growth. Here's an example of how the sunlight can't get to the fish whenever there's dirty water on top of them. The dissolved oxygen procedure. Record the temperature of the water for your DO to see. Remember, leave it in there for a minute. The number with the green/brown background is the temperature. Record it in Celsius. Put the small vial into the water and make sure it's filled to the brim. There may be a little bubble on the top. Drop 2 DO tablets in the vial. Just to let you know, it will overflow. Screw the lid on very tight. Make sure there are no bubbles. And then you can shake it until the tablets dissolve, around 4 minutes. Still shaking. Still shaking. Almost done. Done. Now you let it sit for about 5 minutes to let the color set. And then you compare it to get the saturation and the DO level. First look at the temperature, and then you compare with a chart to find the ppm. This water is 41% saturated. Stop and try it.
Now we'll tell you about turbidity and why it's important. Turbidity is a measure of clarity of water. Turbid water is caused by suspended matter such as clay, silt, organic matter, inorganic matter, and microscopic organisms. Turbidity should not be confused with color. Here's the Secchi disc.
Here is a chart showing low and high turbidity.
Turbid water may be the result of soil erosion, urban runoff, algal blooms, and bottom sediment disturbance such as boat turning up the water in lakes or rivers. Turbid water can cause all sorts of problems. The water absorbs more heat, which lowers the amount of oxygen in the water for plants and animals. It also makes it hard for sunlight to reach plants that are below the surface. The turbidity procedure.
Remove the back off the Secchi disc icon sticker.
Put the sticker on the inside bottom of the cup. Put the sticker slightly off the center.
Fill the jar to the fill line on the label.
Hold the turbidity chart at the top edge of the jar. Looking down into the jar, compare the look of the disk to the chart. Record the turbidity in JTU.
Now it's your turn. Thank you for being in this class and participating in our experiment. We gladly thank you.
We would like to give a special thanks to Aaron Mullins for making this Prezi.